Alrighty, we are zooming through chapter 3 onto 3.4, solving multi-step inequalities. Now again, I know that I've said this a couple times, but these are pretty much exactly like multi-step equations with simple, equalities. The only difference, again, is just going to be that multiplying or dividing by a negative number that we have to be careful about. But we can handle it. No big deal. We got it. We got this. We got it. So, my ridiculousness aside, let's start solving this. The first thing we're going to do is subtract 7. And hopefully everybody knew that that was what we needed to do because the order of operations going in reverse, that should again kind of be a bit like second nature at this point. 9 minus 7 is going to be 2. Now I need to multiply by a negative. Multiply by a negative, which means something special is going to happen here. Flip, flip. Negative 12y is greater than negative 12. That is my solution to this inequality. The only thing that we really have to be sure of when we do these things is that we're following order of operations correctly, and then that new add-on piece, which is if you're going to add, if you're going to multiply or divide by a negative, you got to flip that sign. Alrighty. Example 2. This one's going to be a little bit different, a little bit weird when it comes out, but it's going to be a lot like a case that we did when we were studying distributive property and multi-step equations earlier. So the first thing I'm going to do is distribute. 8x minus 3 greater than, and then I'm going to distribute 4 to the 2x, so that's 8x, and 4 to the 3, which is going to be 12. Now what I would need to do is the same type of rules that I would do with equations, which is trying to lump together all of my x's and try and lump together all of my numbers. So I'm going to go ahead and take the 8 and move it, the 8x, and move it to the left side. Now something very interesting is going to happen here, which is exactly what I wanted. 8x and 8x go away on the left side, but exactly what I didn't want, the 8x and the 8x go away on that side. So what I'm left with is an equation that says negative 3 is greater than 12, which is simply false. Negative 3 is less than 12. So what this implies is no solution. If, however, the equation would have been true, like this said that 14 is greater than 12, that would have said the exact opposite. It would have meant that every single number is a solution, that all numbers are solutions. All right, so we have these new ideas of no solution and infinitely many or all solutions. And we saw the same thing with equations. It's just a little bit different with the inequalities. Now, example 3. Let's see what we can do here. The graph represents the solution of negative 7 times x plus 3 less than or equal to 28. So let's go ahead and just start distributing. Negative 7x minus 21 less than or equal to 28. Now, again, I need to try and collect all of my numbers together on one side and all of my variables together on the other side. So I'm going to add 21. When I do that, I get 49 on the left side. Still, the sign hasn't changed or anything, and negative 7x is by itself. Now, I kind of gave away the fact that the sign is eventually going to change because now I'm going to divide by negative 7. And when I divide by a negative number, even though I get x by itself, that sign is going to change, and this is going to be a negative 7 on the right side. So x is greater than or equal to negative 7. That's what I need to look for in all of these things. Okay, well, they all have 7, but only 2 of them, A and B, have negative 7. So I'm going to go ahead and cross off C and D. Now they both have it filled in, which is good because it's or equal to. The dot should be filled in. But one of them's going in one direction, the other one's going in the other direction. I want x is greater than, which means I want an arrow going to the right, which means I want B. Fantastic. Last little bit here. Application. Of course, I have these four scores that I've gotten in my trivia game, and I need at least an average score of 90 in order to move on to the next round. So what score do I need in my fifth round? So far I have 95 and 91. Ooh, and I had a bad round 3, 77. Yuck. And 89. And then I'm going to have something for round 5. So let's just make that an X. All of that has to get averaged together, and somehow I need to get at least 90. So what's the symbol that I'm going to use to relate this to 90? So this average has to be greater than or equal to 90. Alrighty, I think I can manage that. Now let's try and add together all of these things and combine some like terms. On the top it looks like I'm going to have a 352 when I add all those things together, plus some value over 5 greater than or equal to 90. And now that I have this grouping symbol, this fraction bar here, I need to get rid of the 5 first. So I'm going to multiply both sides by 5. And 90 times 5 is going to be 450. And 5 was positive, so I don't need to change the sign. 352 plus x. And then lastly, just to get x by itself, I need to subtract 352. Which leaves me with an x value that has to be greater than or equal to 98. I have to get a 98 or higher on my last round in order to move on. That's going to be a tough one, but here goes. Alrighty, I will see you guys in class. Let me know if you have questions, write them down. We'll talk about it, we'll figure it out. Good luck on the assigned problems, and I'll talk to you later.